Lecture 5, Module 3, Measure Stage, Part 2, Central Limit Theorem. We're in the measure the process stage of measure. We did the first pass analysis, we did distributions, and now we're going to talk about the Central Limit Theorem. Because we'll sometimes be dealing with, from time to time, with non-normal distributions, and often with some small data sets, it's important that we know something about the Central Limit Theorem. The Central Limit Theorem is really a fundamental and very important principle that underlies many of the statistical analyses that are performed on a daily basis, including, as we'll see, confidence intervals and control charting. In very simple language, what the Central Limit Theorem tells us is this. The averages of samples, once again, the averages of samples, will have a normal distribution regardless of what type of probability distribution the samples are taken from. For example, the averages of samples taken from a Weibull or an exponential distribution will have a normal distribution. So if we look at these sample distributions of means of samples from all of these distributions, they will be normally distributed if the sample size is large enough, and generally n is greater than 30. So any one of these types of distributions, if you took samples from them and averaged them, the averages will plot out as normally distributed. Now there are three important things to realize from the Central Limit Theorem. One, the mean of the sampling distribution of means is equal to the mean of the population the samples were taken from. Two, the variance of the sampling distribution of means is equal to the variance of the population the samples were taken from, divided by the size of the sample. And three, for normal populations, the sampling distribution of means will be normal, and for non-normally distributed populations, the sample distribution of means will become increasingly normal as the sample size increases. As was said in point 3, for non-normally distributed populations, the sampling distribution of means will become increasingly normal as the sample size increases. For very strange, very non-normal distributions, for example, like that uniform distribution, this will be true when sample sizes are greater than about 30. And this is where the widely believed to be statistically valid, the sample size must be greater than 30, is derived from. It's not true. It's only true in those cases where very strange distributions are being sampled. You have to have significantly large sample sizes to be able to treat it as normal data. But for distributions that are closer to normal, smaller sample sizes can be more than acceptable, quite acceptable. You don't need 30 all the time. So, armed with an understanding of frequency distributions and now the Central Limit Theory, we are ready to move into process capability.